Hello. We're going to go over the point quarter calculations today from lab this week at the Rice Center. I'm just going to share my screen. All right. So when you get your data, it's gonna look roughly like this. The only difference is we're going to order the common names so we can look at the observed species a little easier. So what you're going to do is select the column that the common name is in, or the genus species, whichever one you prefer. I'm doing common name just because it's a little easier to recognize. And you're going to go up here to this sort and filter and go A to Z. And it's going to ask you if you want to expand the selection, and you do want to expand the selection because it's going to include the transect, the point, the quarter. Mostly what we need is the distance, the DBH. So that didn't really do anything on my sheet because I already had the data ordered. So what next you want to do is set up your table. You're going to have the common name, total DBH, and average DBH, and number of occurrences. I do this a little bit different than, it's just the same as what the calculations tutorial PDF does. It's just I do it in a little different of an order. If you're using that handout, you'll see that in a minute. So now you just want to go through all the data and list all the observed species that we're seeing in the forest. So this is your whole forest right here, all the species we saw. Next, we're going to sum the total DBH of each species. So what you want to do is sum these two for each species. So American holly only has 2, but when you get down here to loblolly, there's a little bit more than 2. So you can go equal and hit the sum function, and then it'll allow you to sum the DBHs for said species. I'll do it one more time. Well, this is only one. But you'd put equal sum. I'm only going to go through those 2, but you just want to finish those out and get all your total DBHs. Then you're going to list the total number of observations of each species. For American holly, it's 2. For black gum, we saw 1. And you just want to go through and list all of them. If you sum to check, you should have, I believe it's 100. The average DBH is going to be the total DBH divided by N. And then this is just going to be 10 divided by 1, so it's just 10. But you go through and do that for all of them. The number of occurrences is the number of times you saw it. It's going to be the same as your N column. And go through all of them. Then what you're going to do is we're going to copy the names total. You're going to copy the names and the N column, and we're going to put it into another table. I've already done that right here. Now we're going to go into calculating the rest of it for the lab. The headings that you're going to have are going to be the ones you just copied, common name and the N. You can include the genus and species right here. You're going to, in the table on your appendix, they don't require you to put the abbreviated species. You can if you want to. I just have it organized by the alphabetical arrangement of the common name. If you use the genus and species, order it with the genus and species. So for you're gonna have for all the column headings, you're gonna have relative density, density, average DBH, which we're gonna copy from the table that we just did. And then we're gonna calculate average basal area, total basal area, relative basal area, occurrences we copy from the table that I just did. And then frequency, relative frequency, and importance value. So the first thing we're going to do is the mean point to plant distance. We're going to go back to this data sheet, and under the column that's titled distance, we're going to go all the way down and get the average or the mean, which I already have right here. I'm going to do it again. You can type in equals and average, and then you just take the average of the whole column. It didn't work. So this is our mean point to plant distance. There it is. So that's about 3.18 meters. Next one is mean area per plant, which is just going to be this value. Oops, this value squared. And then total density of all trees, all species of trees in the forest that we sampled. That's going to equal the number of total hectares that we sampled, which is 10,000 right here. So take that number and divide that by the mean area per plant. Okay. So next, we're going to go on to the rest of these calculations in this column. First one is relative density. That one is going to be the n divided by 100, and then multiply it by 100. So it was n for black gum 1 divided by 100 times 100. So, just 1, and you do that for all your species. And if you notice, I just dragged my formula down and it copied easily, and the formula didn't get messed up. And most of these are going to be the same. You can drag the formula and they won't get messed up. Messed up I mean is in the formula doesn't copy correctly. But it's always good just to make sure that they do copy correctly, because the errors will multiply very quickly. A way to check this is by summing your columns. So we're just going to sum this column and it should equal 100. Okay. I always sum all my columns. The next thing that we're going to calculate is the density. That's going to be the relative density divided by 100 times the total density. So relative density divided by 100, and then times the total density, which is what we calculated down here. One more time. Relative density divided by 100 times total density. So this is one of the ones that the formula will not copy correctly. Cheat really quick. Okay, so we've got our density calculated, and this number, the sum of all of these should equal this. So we're going to check that. And indeed it does. So the next column is average DBH, which we calculated back on this data sheet right here. So you would copy that down and paste it onto this sheet so we can use it for the rest of the calculations. Average basal area is going to be, the formula is 1/4 times pi times the square of the average DBH. So this is what it's going to look like. It's going to be 0.25 times parenthesis 3.14 for pi, and multiply that times the average DBH. Oops. You just want to make sure everything's separated. If you're doing it in Excel, it's a lot easier if you're not comfortable with Excel to do it by hand. But the formula again is 1/4 times pi times the square of the average DBH. Okay, we're gonna do it one more time. 0.25 for times 3.14 times the square of the average DBH. I doubt this formula will carry. So I'm just going to go through and make sure the number I'm multiplying in the formula is the right number that should be with the average DBH, and it looks like it is. Okay, so for total basal area, we're going to do the density times the average basal area. So it's going to be density times average basal area. One more time, density times average basal area. All those formulas transferred nicely. So we're going to sum this column. Then we're going to calculate the relative basal area, which is going to be the total basal area divided by the sum of this column, and then multiply that times 100. So it's total basal area divided by the sum multiplied by 100. All right. One more time. Total basal area divided by the sum of the column times 100. All right. 1 second while I copy the rest of these. All right, so number of occurrences was a column that you copy from the first set of calculations we did with the raw data. Once you've got that copy down, we can calculate the frequency of each species. That's going to be the number of occurrences divided by 25 and multiply that all by 100. One more time, occurrence divided by 25, multiply by 100. All right, that copied perfectly. All right, we're going to take the sum of this column and right now we're going to calculate the relative frequency. The relative frequency is going to be the frequency for each species divided by the sum of the column multiplied by 100. One more time. It's going to be the frequency divided by the sum of all the frequencies times 100. And we'll see how that copies. And it doesn't. Okay. So the last one we got to calculate, and I swear we're almost done, is the importance value. That's going to be the addition of the relative density, the relative basal area, and the relative frequency. So relative density plus relative basal area. Oops. And then the relative frequency. Another thing I forgot to mention, all your relatives, relative density, relative basal area, and relative frequency, they should all sum to 100. If they don't, you've done something wrong in your calculations and you can go back and check. But as long as you go through this data sheet, you get to relative basal area and you sum it and equals something other than 100, you can go back and check and it's somewhere in here. If that's 100 and you get to relative frequency and you have the same problem and this is not 100, the problem. You calculated something wrong in frequency or something. So those all equal 100, so we're good. So we know that our importance value is correct. That looks like that formula copied nicely. So this is going to be one of the values you're going to reference a lot in your paper. We're trying to figure out the composition of this forest, and that's going to help you determine that. The last thing I wanted to talk about was the appendix. You're going to have one table, and that's what this is right here. You're going to have all your relative values and your density and your importance value. Like I said earlier, you can have your common name, or you can have your genus and the species, or you can have both. I just used the common name because that was what was in the example appendix. Then you're going to have two figures like this. The first one is common name on the x-axis and the density on the other axis. And figure 2 is going to be common name on the x-axis with the importance value on the y-axis. And if you're in a section that needs to print out your reports, I recommend using this pattern right here to help save on ink. If you double click on your bars and you go to the little paint bucket symbol, click fill, you have a bunch of options here. Hit pattern fill, and then you can use any of them any of these. I just like that one because it was simple, but you can pick any of them. Straight lines, graph. I like that one. The only thing I wanted to note on these, besides making it scientific format, was making sure that your x-axis, your common names, are big enough that you can see them. I have these at 12 font size, which is plenty big enough to see them. So that's the only comment I wanted to make. Otherwise, if you have any questions about making your graphs, let me know. Otherwise, good luck with your report. Happy writing.